The purpose of this small series of videos is to go through the entire process of creating online maps for a particular purpose and organizing those maps and a number of other resources into a application called a story mapping project. And the idea of a story mapping project is to use maps and related information to present a lesson, a story, a product pitch, or just about any concept that one would want to communicate to the public with the use of maps and geography, and something that is available with nothing more. The client has to have nothing more available than a web browser. So let's start with the mapping side of this. And I have a map project here which I'll slowly expose so that I can explain what the purpose of this project is and what materials I'm going to put together into this overall story map, which will be a very impressive product at the end, which I think that you'll appreciate and hopefully see some application for in your own work or in your own studies. The idea around this whole project is to look at earthquake risk, kind of a natural hazards, natural disasters study, and combine the mapping and idea of earthquake risk with areas that we can assume have what is called a high social vulnerability index, meaning areas that are not resilient communities, areas in which a natural disaster would have especially bad impacts for various reasons. So let's go through this. The first piece of data is a relatively straightforward one, and that data is a map of the seismic zones in the United States. This is easily available from the United States Geologic Survey, being a standard data set. It's easy to find. It comes as a shapefile. And what we're looking at here is the probability, or actually the amount of shaking that will occur at each location with a certain probability over the next 50 years. And not to get into the seismology of this too awful much, but what this shows here is that the darker the color actually here, the higher the G-force is expected to be when earthquake activity occurs over the next 50 years or so. So again, I didn't do a very good job of explaining the seismicity of this, but areas that are in red have a distinct possibility of having an earthquake that shakes as much as 2 times the force of gravity, which is a devastating earthquake intensity. It's a little hard to see where this stuff is, so a good map usually has some sort of a reference. And with a state's boundary map of the United States, and I'm zoomed into the continental United States, we can see that, as expected, California is our most seismically active state. What people don't always realize is that the northwest of the United States, even offshore, is a very important seismic zone. But the one that I'm going to focus on in this development of this conceptual development is the seismic zone that is centered around the Missouri Boot Heel area right there, and is called the New Madrid Seismic Zone, which is actually this small area in here has the greatest potential for a massive earthquake of any part of the United States. So that's a very interesting thing that most people don't realize that will be revealed in the story map once we develop it. So this is what seismicity looks like in the United States. And what's the lessons to learn from what I've shown you in this first video. I'm keeping videos down to about 8 or 9 minute pieces for each video for several reasons, pedagogical and technical. But what this shows is that first, a reference layer is very important so people can recognize where the features are that are being highlighted, and secondly, the fact that it is really quite easy and productive to look for data sets from places such as the United States Geologic Survey, or these states came from the National Atlas, the state boundaries. And in a future lesson, I think I'll talk about finding data sets and finding the most productive places to look for data sets to tell a story. But for now, I'm going to break this video and then continue shortly.